So express the following complex number in polar form. So my complex number is z is equal to minus root 3 plus 1i. And I'm just going to write down underneath them the real part is a and the imaginary part is b. And I now want to express that in polar form, which is written as z is my complex number, or times cos of theta plus I sine of theta. Now, if we just look at our complex number, first of all, on the Argand diagram. So I have my reals and my imaginaries. I'm going back root 3 and up 1i. So it's probably around here. It doesn't necessarily have to be in the right location. It's just to help me draw it. So that line from the origin to the coordinate z is radius, so or modulus, we'll know that in a couple of minutes. And then I'm looking for the angle here, which is theta, or also known as the argument. The argument is the angle. So I need to go off now and find or and theta in order to put it into my polar form. So in order to find or, we're using our modulus formula, which is a squared plus b squared. So or is equal to the square root of negative root 3 all to be squared. Just put that in brackets if you're using your calculator, just to make sure that it squares the negative. So or is equal to positive 3 plus 1, which is root of 4, and the square root of 4 is 2. So put simply, the radius or the modulus of this complex number is 2. I'm now going to go off and find my angle, my argument, which is found by finding the tan inverse of b over a, which is also the same as y over x, depending on the letters you're using, but let's stick with b and a for this one. So filling that in, I get theta is equal to tan inverse of 1 over negative root 3. And when I type that into my calculator, in degrees it's coming up as negative 30 degrees, or if you're working in radians, it's coming up as negative pi over 6. So it's up to you whether you're using degrees or radians. I'm just going to do it out in both forms for this question. Now, if I come over to my diagram and mark in negative 30 degrees, negative 30 degrees is down around here. It's not technically what I want. I want the positive angle. So 9 times out of 10 when you do these questions in an exam, it's going to ask you to write it in the form of 0 to 360 degrees. So what I have to do now is basically find the reference angle for negative 30. I want to basically find the equivalent angle to negative 30. And you can probably see from my diagram that it's 150 degrees, because if I just come over to my diagram here, this angle in here is also going to be 30 degrees. And basically what I'm doing is I'm going back 30 degrees from this real axis, which is 180 degrees. So that real axis is 180 degrees. So if I basically go 180 degrees minus 30, it'll bring me back to 150 degrees. And that's basically what I want to find. So in other words, my angle is not negative 30. I want to use angle as 150 degrees. Another way you can look at that is basically take a look at the picture. This straight line must add up to 180 degrees. I've already marked on 30 degrees, so the remaining green angle must be 150. So a quick way of looking at that is basically add on 180 degrees to your negative 30, which brings me to 150 degrees. So there's many different ways you can kind of get to your 150 degrees. So there's 2 or 3 different ways. If I'm using it in radians, my angle would equal to the equivalent will be 5 pi over 6, won't it? So we'll write that in as well. So 5 pi over 6. So now I'm coming down to my final answer. So my complex number or is equal to, or times cos theta plus I sine of theta is giving me or, which is my modulus, which is 2, times cos theta, which is 150 degrees, plus I sine 150 degrees. Or if we are working in radians, it will be 2 times cos of 5 pi over 6 plus I sine 5 pi over 6. So just make sure your calculator is in degrees or radians, depending on what way the question is asking you at home.